At the break of a neon dawn in the year 2200, I boarded the starship Prometheus, our vessel built on centuries of scientific ingenuity and daring ambition. It was the culmination of human dreams to journey beyond our Milky Way, to cross the intergalactic gulf between our home and our cosmic neighbor, the Andromeda galaxy. Andromeda, also known as M31, is a sprawling spiral galaxy roughly 2.537 million light-years away from Earth, a majestic mirror of our own cosmic structure. But today, thanks to breakthroughs in faster-than-light travel and quantum manipulation of space-time, what was once a distant myth now lies within our reach. I remember the early days. As a child, I'd lie on dew-kissed grass and stare up at a sky punctuated with distant, flickering lights, imagining worlds far beyond. Back then, the idea of leaving Earth was pure fantasy, a dream painted in the hues of nostalgia and wonder. By the dawn of the 23rd century, humanity's relentless curiosity had ushered us into an era where such dreams weren't just possible, they were our reality. We had built spacecraft powered by quantum singularity drives, devices that harnessed the principles of Einstein's relativity and the mysteries of dark energy to bend space and time. Our journey began on Earth's launch pad, a bustling nexus of interstellar commerce and scientific collaboration. Scientists recalled how, in the 21st century, instruments like the Hubble and James Webb Space Telescopes captured Andromeda's splendor in unprecedented detail. Back then, Andromeda was a tantalizing enigma, its billions of stars and swirling dust lanes only hinted at in distant photographs. Before departure, I took a moment to marvel at the evolution of human achievement. Our ancestors had overcome gravity with rocket science and charted the cosmos using rudimentary telescopes. Their dusty blueprints and speculative theories laid the groundwork for what we now took for granted: navigation through the stars. The Prometheus was a fusion of legacy and innovation. Its hull reinforced with nano-engineered alloys, its propulsion system based on the Alcubierre drive concept, originally proposed by physicist Miguel Alcubierre in 1994, that now allowed us to compress and expand space in a controlled manner. In this way, we could effectively ride the wave of spacetime, sidestepping the light speed limit and reducing a multi-million-year journey to a matter of months. The crew, a diverse ensemble of scientists, engineers, and explorers from every corner of Earth, buzzed with anticipation. Every conversation was punctuated by references to milestones, quantum entanglement communication arrays, the stabilization of wormhole gateways, and even recent advances in AI that could monitor the health of our spacecraft in real time. It was a time when human ingenuity had fused art, science, and spirit into one collective heartbeat, resonating with the rhythm of the cosmos. With a resonant hum and a flash of iridescent light, the Prometheus broke free from Earth's gravitational cradle. Outside the observation dome, space revealed itself as a tapestry of glowing nebulae, dense clusters of ancient stars, and dark voids that whispered of untold mysteries. The quantum drive activated, a controlled burst of exotic matter manipulating the fabric of spacetime. To the untrained eye, it seemed as if we were being drawn into a vortex of light and color, reminiscent of the aurora borealis magnified 1,000 times. Yet beneath this breathtaking beauty lay the cold, precise science of quantum physics, the same principles that had been refined over centuries to bring us here. During the journey, time seemed to dilate and contract. Hours merged into days, and days into weeks. The voyage was a meditative passage through space, a reminder of the vastness of the universe and our relatively fleeting existence within it. I recall staring into the observation window and contemplating how the very laws of physics, long considered immutable, had become our allies in this adventure. Relativity, quantum mechanics, and the emerging field of space-time engineering worked in harmony. Their interplay, a symphony that allowed us to traverse distances that would otherwise render us mere specks against an endless sky. The Prometheus was not simply a vessel, it was a self-contained biosphere. Inside, advanced hydroponic gardens provided a constant supply of fresh produce, while synthetic ecosystems recycled water and oxygen with near-perfect efficiency. The ship's interior was a blend of futuristic minimalism and organic design, a quiet echo of Earth's diverse biomes now rendered in holographic displays and sustainable materials. In these quiet moments, as I wandered through corridors lined with softly glowing panels, I couldn't help but think of how far humanity had come from the days when survival was a daily struggle on a blue planet teeming with chaos. Beyond the routine of navigation and life support, our journey was punctuated by moments of cosmic wonder. At one point, as we navigated through a dense interstellar cloud, sensors detected an unusual concentration of dark matter, a phenomenon only theorized in the early 21st century. Dark matter, the mysterious substance that does not emit or absorb light, but exerts gravitational influence, has long been one of astrophysics' most perplexing puzzles. Modern theories suggest it comprises roughly 27% of the universe's mass-energy content. Here, in the void between galaxies, we observed its subtle effects in real time, as the gravitational contours of the cloud gently bent the paths of nearby stars, and even our own course. Then there were the encounters with rogue asteroids, ancient remnants of planetary formation that now drifted through space like celestial cast-offs. Each close call was a reminder that the universe is not a neatly ordered system, but a chaotic, ever-evolving arena of forces. Advanced radar and laser systems allowed us to map these wandering rocks with incredible precision, and onboard AI swiftly calculated maneuvers to ensure our safe passage. It was as if the cosmos itself was testing our resolve, challenging us to prove that our technological triumphs were not just theoretical but practical responses to real dangers. One memorable moment occurred when we passed near a pulsar, a rapidly spinning neutron star emitting beams of electromagnetic radiation like a cosmic lighthouse. The pulsar's clockwork precision was staggering, its pulses measured in milliseconds echoed across the void. Observing it reminded us of the enduring principles of physics, the same immutable laws that governed everything from the smallest subatomic particles to the largest galaxies. In that moment, the pulsar seemed less like a hazard and more like a guardian of the cosmos, its rhythmic beating a reminder of nature's relentless order amidst apparent chaos. But the journey was not solely about scientific exploration. It was, at its heart, a profoundly human experience, a quest for meaning amid the infinite. In the quiet solitude of space, with the Andromeda galaxy looming ahead like an ancient dream waiting to be awakened, I found myself reflecting on what it meant to be human. We had long looked up to the stars as symbols of hope, freedom, and the relentless pursuit of knowledge. Now, as we sailed towards Andromeda, these symbols became our reality. There were evenings when the entire crew gathered in the central observatory, a domed chamber with panoramic views of the cosmos. We exchanged stories of our lives back on Earth, our dreams and regrets, and our hopes for the future. One of the senior navigators recalled the days when humanity's greatest hope was to explore our own solar system. Today, we were stepping into a realm that was once the exclusive domain of science fiction. In these moments, the boundaries between past and future blurred, and we became both the heirs and the architects of a legacy that spanned millennia. I often thought about the early pioneers, astronomers who first mapped the stars with rudimentary telescopes, engineers who built the first rockets, and visionaries who dared to dream of interstellar travel. Their achievements, once confined to dusty archives and faded images, had grown into the vibrant tapestry of our present. And now, every star we passed, every nebula we marveled at, was a testament to their unwavering belief in the power of human potential. Let's take a moment to unpack the science behind our journey. The distance to Andromeda is immense, over 2.5 million light-years from Earth. Yet, thanks to our quantum singularity drive, we were able to compress that distance by temporarily warping space-time. This technology, built upon the theoretical foundations laid by Einstein's general relativity and refined through decades of experimental breakthroughs, created a bubble around the ship. Within this bubble, normal time and space were distorted, allowing us to effectively skip across vast cosmic distances. Critically, our drive relied on a stable form of exotic matter, a substance with negative energy density, once a purely hypothetical construct. Decades of research had transformed it into a reliable tool for interstellar navigation. Researchers had mapped the gravitational fields of distant galaxies with unparalleled accuracy, ensuring that our warp bubble could navigate the complex tapestry of cosmic forces without causing destructive interference with nearby stars or black holes. In parallel, our communication systems employed quantum entanglement to exchange information with Earth and other human outposts across the galaxy. This instantaneous communication, long thought impossible due to the speed of light barrier, was achieved by exploiting the non-local properties of entangled particles. Although the detailed mechanics of this process remain shrouded in mystery, the practical benefits were clear. We could share discoveries with scientists back home in real time despite the unimaginable distances involved. As we neared the outskirts of the Milky Way, our sensors began picking up anomalies, subtle fluctuations in the cosmic microwave background that hinted at interactions with intergalactic matter. One theory proposed that our galaxy was not isolated but rather part of a larger cosmic web, where streams of gas and dark matter connected galaxies like nodes in a grand universal network. These streams, remnants of the Big Bang's chaotic aftermath, had long been theorized but were rarely observed directly. Now, as we sailed through these invisible currents, we were privy to a dynamic, living universe, a reminder that even in the void of space, there is structure, energy, and history. One of the most profound moments of the journey came when we encountered a region of space where the density of intergalactic gas was higher than expected, a cosmic relic from a long-dormant epoch of star formation. Detailed analysis suggested that this gas cloud was enriched with heavy elements forged in the hearts of long-dead stars. It was as if we were witnessing the echoes of an ancient cosmic cycle, a cycle that had given birth to galaxies, nurtured stars, and sown the seeds for life. For a brief moment, the cold equations of astrophysics gave way to a deep, almost spiritual awe. Here, in this silent expanse, lay the relics of creation itself. After months of travel that felt both eternal and fleeting, the Prometheus began its deceleration sequence as we approached the outer spiral arms of Andromeda. The galaxy's luminous core, a seething concentration of stars and cosmic phenomena, came into view, radiating an otherworldly glow against the cosmic backdrop. Our instruments recorded an astonishing array of data, from the intricate dance of star clusters to the faint glimmer of supermassive black holes at the galaxy's heart. It was here that the full weight of our achievement settled in. We were the first humans to set foot on a galaxy outside our own, a milestone that would forever redefine our place in the universe. Andromeda was not just another dot on a map. It was a vibrant living entity with its own history, mysteries, and potential for discovery. Its spiral arms, winding gracefully like the arms of an ancient dancer, beckoned us to explore further, to delve into its hidden secrets and to understand the forces that had shaped its destiny. But beyond the science and the technology, what resonated most deeply was the human element of our journey. Each crew member carried with them the weight of centuries of hope, struggle, and perseverance. We were more than mere travelers. We were emissaries of Earth, bearers of its stories, its cultures, and its indomitable spirit. In the quiet moments before landing on a terraformed outpost orbiting one of Andromeda's smaller companion moons, I found myself reflecting on the nature of exploration itself. It is not only a physical act, but a profound expression of our desire to understand, to connect, and ultimately to transcend our limitations. I recalled how, in earlier centuries, journeys to unknown lands on Earth were fraught with peril and wonder. Explorers like Magellan and Columbus risked everything to chart new territories. Today, our voyage was no less courageous, a leap not into the unknown geography of our planet, but into the boundless canvas of the cosmos. And just as those early navigators left indelible marks on history, so too would our journey inspire future generations to look beyond the horizon, to dare the impossible, and to dream in cosmic scales. Before we proceed to the next chapter of our Odyssey, a brief word from our sponsor. Imagine a world where every household has a glimpse of the stars at the push of a button. Astrolink, the leading provider of interstellar communication networks, has made it possible to connect remote outposts across galaxies with crystal-clear clarity. With their quantum-synchronized arrays, staying in touch with loved ones light years away is no longer a fantasy. Astrolink's technology is dedicated to ensuring that the bonds of humanity remain unbroken no matter how far we roam. For more details, visit their intergalactic portal and discover how you too can be part of the cosmic conversation. As we began our descent toward Andromeda's outer system, the artificial gravity of the Prometheus reasserted a comforting normalcy. Our landing craft separated from the main vessel with precision-engineered choreography, entering orbit around a small ice-bound moon orbiting a minor spiral arm. This moon, designated Nova 3, was selected for its potential as a base for further exploration, a stepping stone into the deeper mysteries of Andromeda. Stepping out of the landing craft was surreal. The surface was a frozen desert, bathed in the gentle luminescence of distant stars. In that moment, every hardship of the journey, the isolation, the unknown perils, the incredible distances, seemed to melt away. Instead, there was a quiet, overwhelming sense of connection to the cosmos. The ground beneath our feet, though alien, felt like a continuation of Earth's own story. A reminder that, despite the void between galaxies, the same fundamental forces of nature shaped every rock, every star, every living thing. We set up a small outpost on Nova 3, an amalgamation of inflatable habitats and regolith-based structures engineered for long-term sustainability. The outpost would serve as a hub for scientific inquiry, a place where we could study Andromeda's composition, map its star systems, and even test new life support systems designed for deep space colonization. Each data packet transmitted back to Earth was a message of triumph. Humanity had not only reached another galaxy, but it had also begun to unravel its many secrets. In the quiet hours of our first Andromedan night, a night defined not by the familiar glow of a moonlit sky but by a tapestry of stars in a foreign galaxy, I found myself pondering the future. What does it mean to be human when you are literally standing on the threshold of an entirely new cosmic chapter? Our journey was not merely a scientific expedition, it was a voyage of self-discovery. It forced us to confront questions that had long lingered in our collective consciousness. What is our place in the universe? How do we balance the weight of our past with the limitless promise of our future? Our discussions were as philosophical as they were technical. In late-night sessions, we debated whether the human spirit was intrinsically tied to Earth or if it could flourish amidst the stars. Some argued that our very identity was shaped by our planet's unique environment, the blues of our oceans, the greens of our forests, the gentle pull of gravity. Others contended that human creativity was not bound by these constraints, that our capacity for adaptation and wonder meant that we could redefine home wherever we roamed. Perhaps the truth lay somewhere in between, that our journey to Andromeda was as much an exploration of our inner selves as it was of outer space. Now, as I record these reflections from a quiet observatory module on Nova 3, I am acutely aware that this journey is only the beginning. Andromeda, with its swirling arms and untold mysteries, beckons us to explore further. Already, plans are underway for deeper probes into its central bulge, a region teeming with supermassive black holes and ancient star clusters. Future missions aim to establish permanent research stations on several of Andromeda's moons, transforming these barren orbs into hubs of human knowledge and culture. The legacy of our journey will be measured not only in the scientific data we collect but also in the way it reshapes our collective imagination. For centuries, humanity looked up at the stars and wondered what lay beyond. Today we have answered that call. Our journey to Andromeda is proof that no matter how vast the darkness or how daunting the unknown, human ingenuity and perseverance can light the way. I often think back to those early days when interstellar travel was relegated to the realm of science fiction. We now stand on the precipice of a new era, one defined by both exploration and introspection. The technologies that made this journey possible, quantum drives, warp bubbles, and entangled communications, are themselves monuments to the human capacity for innovation. And just as our ancestors harnessed the power of the telescope to chart the heavens, we have embraced the tools of our era to bridge the gulf between galaxies. So, as the Andromedan horizon beckons and the stars of a distant galaxy shimmer with promise, I invite you to join us on this extraordinary journey. Whether you are a scientist, a dreamer, or someone who simply yearns to understand the mysteries of the cosmos, remember this: the journey is as important as the destination. Our footsteps on Nova 3 and our data relayed back to Earth are not just records of a scientific mission, they are part of an ever-growing chronicle of human exploration. One day, perhaps, our descendants will look back on this era as the turning point in our history, the moment when we dared to venture beyond the safe confines of our solar system and reached out to touch another galaxy. And in doing so, we will have reaffirmed a timeless truth that every end is merely a new beginning, and that the spirit of exploration, curiosity, and wonder is what truly makes us human. As I sign off from this outpost, watching the Andromedan core blaze with the light of billions of ancient suns, I am filled with hope. Hope that our journey will inspire new generations to continue exploring, questioning, and dreaming. Hope that the boundaries of human achievement will continue to expand, just as the universe itself does. And above all, hope that the legacy of this journey will remind us that we are all, in some small way, citizens of the cosmos, each of us connected by the light of distant stars and the timeless call of adventure.